Welcome to Get Academy Global. So now, as we discussed in the last class about the Poynting theorem and the Poynting vector and the power density and how to calculate the power from the power density. So we will solve few questions from the Poynting vector and then we will move to the next topic, that is normal incidence. So just once message me in the comment box so that I can know how many of you have come, and then we will start the discussion. Good evening, Lakshmi. Good evening, Urvashi, and good evening, Iti. So now we are going to discuss the question, and that is the workbook question. So the question number 11 from the workbook. Okay, you are having the question number 11 from the workbook. A material has conductivity. Okay, a material has conductivity sigma is equal to 10 to the power minus 2 mho per meter and relative permittivity 4. We have to find the frequency at which the conduction current density and the displacement current density are equal. Okay, you have to find the frequency, find f at which JC, magnitude of JC is equal to magnitude of JD. So this you have to calculate. So how can we calculate? Can anyone answer this question? Good evening, Hemant. Yes, everyone share the video to the other groups so that other students can also come and can get this notification that the session has been started and we have started solving the questions. So everyone, Urvashi, Iti, Hemant, Lakshmi, all of you share the session in the Telegram group, in others Telegram group. Good evening, Rishika. So this is the question. Those who have joined from the starting, they can solve, and those who have joined just now, the question is a material has the conductivity sigma and relative permittivity 4. You have to find the frequency at which the magnitude of current density, conduction current density and magnitude of displacement current density are equal. So what should be the approach? We know that the magnitude of the conduction current density, that means sigma into E, and magnitude of displacement current density means omega epsilon into E, and this E and E will get cancelled and we get sigma is equal to omega epsilon. So from here we get the frequency is equal to sigma upon 2 pi epsilon. So the frequency sigma, that means 10 to the power minus 2 divided by 2 pi epsilon r, that means 4, and epsilon naught, that means 10 to the power minus 9 divided by 36 pi. So this is, when you calculate it, what you get? So this is 2 pi and this is 36 pi, so you will get 18, and it is 18, and it is 10 to the power 7, right, divided by 4. So if you write it in megahertz, so that is 180 divided by 4, which is 45 megahertz. Okay, so the correct answer for this question will be 45 megahertz. Yes, Hemant, correct. We have already calculated the frequency. We have already discussed about the frequency at which the magnitude of the conduction current density and displacement current density are equal. So I am giving you another question, question number 12. In a non-magnetic medium, E is equal to 4 sine 2 pi into 10 to the power 70 minus 0.8x and ay cap. So the question is, you have to find first intrinsic impedance, second time average Poynting vector, that means P average or power density, and third total power crossing 100 centimeter square area of plane 2x plus y equal to 5 in microwatt. Total power crossing 100 centimeter square. Yes, total power crossing 100 centimeter square of plane 2x plus y equal to 5. This is the question. Solve this question. Okay, so we are having the next question, question number 12. This is a non-magnetic medium and electric field is given. We have to find the eta, time average Poynting vector, and power crossing through this 100 centimeter square of plane 2x plus y equal to 5. So let's discuss this question. So we have the standard form of the electric field, which is E naught cos of omega t minus beta z for any lossless medium. Okay, for any lossless medium, the expression of the electric field is this. So we can find that this E naught is equal to 4 here, omega is equal to 2 pi into 10 to the power 7 radian per second, and beta is equal to 0.8. It is given like this. Okay, now we know that this eta is equal to how much? This is a non-magnetic and lossless medium, so this is 120 pi root over epsilon r. So ultimately you have to find the epsilon r. So how can you find this epsilon r? Root over epsilon r. We are now discussing the first part. So this beta is given, so this beta is nothing but omega by c root over epsilon r. Beta is 0.8, omega is 2 pi into 10 to the power 7 root over epsilon r divided by 3 into 10 to the power 8. So it is now this 10 raised to power 7 and this point decimal and this 10 raised to power 8 will get cancelled, and we will get 12 by pi. Yes, root over epsilon r will be 12 by pi. Okay, so now we will substitute this 12 by pi here, and we will get 120 pi divided by 12 by pi. So it is 10 pi square ohm. So the eta will be 10 pi square. Good evening, Yogita. So 10 pi square, that means option C we are getting. Yes, option C we are getting, right? Now next we have to find this time average Poynting vector, and this time average Poynting vector is calculated as P average is equal to E naught square upon 2 times of magnitude of eta and the direction of propagation. The direction of propagation is x. Here we can see that, oh, this is x. Okay, so here it is given that the direction of wave propagation is x. So the direction of wave propagation is now x. Now E naught is 4, so it is 4 square divided by 2 into 10 pi square into direction of propagation ax. So when you solve this, you will get some time average Poynting vector. Now tell me, what is this time average Poynting vector you are getting? 16 upon 20 pi square. How much you are getting? (16 upon 20 pi square). So I am getting 81 milliwatt. 81 milliwatt per meter square. Are you getting the same? 81 milliwatt we are getting. Okay. Now we want to calculate that power crossing through the area. Power crossing through the area. So the power is integration over the surface, time average Poynting vector over the area, that is 100 centimeter square. So let's write it as differential surface ds. Now we can also write it as integration over the surface. The time average Poynting vector is a vector quantity. Okay, so this is a vector quantity. So it is 81 ax cap. The 81 is its magnitude and ax cap is the direction, and milliwatt, that means 10 to the power minus 3 will be there. Similarly, this ds is having some magnitude and the direction, and this 10 to the power minus 3 I am writing in the outside. Now what is the normal vector? What is the normal unit vector of a plane? How do you calculate the normal unit vector of a plane? Since the phi, that plane is given as 2x plus y minus 5, if you want to calculate the normal unit vector, you have to calculate the gradient and divide it by magnitude of gradient. Okay, so when we calculate the gradient of this, we get 2ax. When we differentiate with respect to x, we get 2. When we differentiate with respect to y, we get 1, and that is divided by root over magnitude of this gradient, which is root 5. So this is the normal vector. So now we will substitute this. Now we will substitute it here. 81 is constant, which is outside the integration, and the 100 centimeter, this is 100 centimeter square, it is given. Okay. Now integration over the surface, when we take the dot product, it is ax dot 2ax plus ay divided by root 5. We have to take the dot product of these two and the ds. So when we take the dot product, you will get 81 into 10 raised to power minus 3 into 2 divided by root 5 into 2 divided by root 5. This you will get 81 into 10 raised to power minus 3 into 2 divided by root 5. Ax dot ax is 1 and integration over the surface ds. So what it shows, integration over the surface ds, what it shows? Yes, it shows the area. So 81 into 10 raised to power minus 3 into 2 into area. And what is the area? Area is given as 100 centimeter square. So 100 into 10 raised to power minus 4 divided by root 5. So let's calculate how much it is coming. So in microwatt we have to calculate, so it is coming as 725 microwatt. 725 microwatt we are getting. Good evening, Kumar. So let's start the new topic, which is reflection of plane wave at normal incidence. Reflection of plane wave at normal incidence. So suppose we are having the boundary, okay. The normal incidence, it means that whenever a wave is traveling from one medium to another, because of the change in the characteristics of the medium, like sigma, mu and epsilon, some portion of the wave gets reflected and some portion of the wave gets transmitted. So in such cases, we have to calculate how much portion of the incident wave is actually reflected and how much of the incident wave is transmitted. So the reflection of the plane wave at normal incidence means we will be having more than one medium and the wave is traveling from one medium to another, and because of the change in their characteristics, this wave, plane wave, is reflecting, some part is reflecting and another part is transmitting. So this is medium 1 and medium 2. The medium 1 is having a characteristics like sigma 1, mu 1 and epsilon 1, and medium 2 is having the characteristics sigma 2, mu 2 and epsilon 2. Now if the wave is traveling from one medium to another, we are saying that this is z is equal to 0. So z is equal to 0 is the boundary, it means the xy plane is the boundary. Xy plane is the boundary. Okay, xy plane is the boundary which is separating the two medium. Now suppose the wave is traveling in the positive z direction, and that is the incident wave, and this is the incident electric field. So let's write, this is the incident electric field, this is the direction of propagation, and this is the direction of magnetic field. Okay, this is the incident wave. Now we are having the reflected wave. The reflected wave is the having electric field in the same direction as incident, and the wave is propagating in the negative direction, and the direction of magnetic field is also inverted and it is now inside the board. We are saying this as x-axis and this is as z-axis, because we are saying this is the medium 2. So medium 2 is defined for z greater than 0 and medium 1 is defined for z less than 0. So if the wave is traveling from the z less than 0 to z greater than 0, so medium 2 is z greater than 0 and medium 1 is z less than 0. This is the incident wave, this is the reflected wave, and now we are going to draw the transmitted wave. This is the reflected wave. This is the incident wave. And yes, we are having the transmitted wave, and transmitted wave and incident wave are having the same direction. Like this. So this is the transmitted wave. All of you got this point? Up to this point, is it clear? Hemant, yes. Rupali, yes. Good evening. So we are saying that overall we are having the two mediums, medium 1 and medium 2, and the medium 1 is having the characteristics, that is conductivity, permeability and the permittivity of the medium, and medium 2 is having the characteristics sigma 2, mu 2 and epsilon 2. And because the characteristics of both the mediums are different, when the wave incident from one medium to another normally, so it is incidenting normally, so when it incident on the boundary, the some portion of the incident wave gets reflected and some portion of the incident wave gets transmitted. So when it is incidented, some part is reflected, so we have to calculate that how much part of the incident wave is actually reflected and how much part of the incident wave is actually transmitted. So we are saying that the z is equal to 0 is the boundary or the interface which is separating the two medium. Medium 1 and medium 2 are separated by this boundary, z is equal to 0, that is xy plane. So this is the boundary, z is equal to 0, xy plane. This is x axis and y is outside the board, because this is z axis, this is y axis, so y is outside the board. If I draw the coordinates, so this is x axis I said, so in anti-clockwise direction it is y and then z. So this is the coordinate. So according to this coordinate, this is cross, that means the magnetic field is representing in the negative y direction, and if it is dot, then magnetic field is in the direction of positive y, because outside the board is represented by positive y. So in this way we have defined the directions of electric field and magnetic field. Is it clear? Hemant, is it clear? Okay, so let's write the expression for incident wave. Okay, let's write the expression for incident wave. So how do we write? So suppressing the time factor, if I consider the electric field as suppressing the time factor, so this is the peak value of the electric field. We know that as wave travels, if it is a lossy medium, then wave amplitude can attenuate. So we are considering the general medium in which we can have the sigma, we cannot have the sigma. We don't know whether it is a air or it is a free space or it is a lossless or it is a conductor or it is a lossy. We don't know. So we will write the equation in general. So that is why we are saying that suppose the incident electric field is having the peak value EI0. So as wave propagates in the positive z direction, because as you can see from the diagram, the wave is traveling in this direction and this is the positive z direction. So we will write e to the power minus gamma 1 into z. Gamma 1 is nothing but the propagation constant of in the first medium. Propagation constant in the first medium. And what is the direction of electric field? So the direction of electric field is x direction, that we are assuming. The direction of electric field in the question can have the different direction, but here in the diagram, if it is the plus axis and it is the direction of electric field, that means the electric field is going upward direction, and that upward direction is the positive x direction. So electric field is having the x direction. Now the magnetic field HIS. So the magnetic field is peak value of the magnetic field, and as wave propagates in the medium 1, it is gamma 1 and z, and the direction of magnetic field is AY. You can also write HI0 is equal to EI0 divided by impedance of that medium. So intrinsic impedance of the medium 1 is, let us say, denoted by eta 1. So E and H is nothing but intrinsic impedance. So EI upon N1 or eta 1, e to the power minus gamma 1 into z and AY cap, and put it equation number 2. So in this way we have written the two equations for electric field and magnetic field for the incident wave. Similarly, we will write it for the reflected wave. What is the expression of electric field for reflected wave? So for the reflected wave, ERS is equal to ER0 e to the power minus or plus. because the wave is now traveling in the negative z direction, it is negative z direction. So when the wave travels in the negative z direction, we should write it here plus, and it is traveling in the medium 1 only. So incident wave and the reflected wave both are traveling in medium 1, so we will write gamma 1, and that is z, and the direction of the electric field is plus x. So it is your equation number 3, and the magnetic field, as we can see in the diagram, it is having the gamma 1 z, the direction is negative and the direction is minus ay, because now you can see that we have denoted it by cross. So magnetic field is denoted by cross, that means it is going inside the board. It is going inside the board means it is minus y, negative y direction. So now HR naught can be written as ER naught divided by eta 1 and e to the power gamma 1 into z and minus ay cap. So put it equation number 4. So in this way you have to write the expression of the field. Okay. So now one more wave is left, that is the transmitted wave. So the transmitted wave is ETS. ETS is equal to ET0 and e to the power minus gamma 2 z and ax cap. Because now wave is traveling in the medium 2, so that is why the propagation constant will change and that will become gamma 2. And because the incident wave, transmitted wave is having the same direction, which is positive z, so that's why we have kept here minus sign. So this is equation number 5. And HTS. Why I am using the S in the subscript? Because I am not considering the time factor. So the S denotes the suppressing the time factor. And here again this HT naught is the peak value and minus gamma 2 and Z, and the direction of magnetic field in the transmitted wave. Direction of magnetic field is represented by dot, so it is the positive y direction. Now we can again write it as in terms of eta, but this time this eta will become eta 2, because eta 2 depends on the characteristics of the medium, and the characteristics of medium has been changed. So that is why the medium impedance will also be changed. Okay. So this is minus gamma 2 into Z and AY. So this is equation number 6. So these are the 6 equations. Yes, Rushikesh, good evening. So those who have joined just now, they can see this whole board and the diagram, and you can ask if you are having any doubt in this diagram. Yes, Bhanu, you are from instrumentation where you can prepare the. Okay, Bhanu, you can prepare EMT. Tell me if you are able to understand Hindi or not, Bhanu Shri. Okay. If you are able to understand Hindi, then for Bhanushri I am telling, in the main channel, that is in the Gate Academy channel, okay, in Gate Academy channel, search EMT double E, okay, EMT double E, search like this, EMT double E, and you can also write my name, and if you write the EMT double E, you will get a playlist of 31 lectures, playlist of 31 lectures, okay. So first of all, watch this 31 lectures, and along with this you will also get one more playlist in which I think 11 lectures are there, which is the crash course, and in this crash course you will be having questions, set of few questions, like 40-50 questions are there, and when you will follow that 31 video lectures playlist along with that crash course, first watch the videos from the 31 playlist, that is watch the theoretical part from that playlist, and once you finish the theoretical part of the chapters like coordinate system and chapters like electrostatic, once you finish the theory part, then go to the crash course, and from there you revise those videos, okay, revise those topics from the crash course, because in the crash course I have not derived anything, okay, just in the crash course I have written some you can say the direct result, okay, for different charge configuration I have written direct expressions, and that you can recall from the crash course. So in the playlist you will get the derivation of each topic, and after completing the theoretical part of any one chapter, go to this crash course and revise those topics from the crash course, and along with that we are having the set of questions in the crash course, so solve that crash course questions, okay, and then practice like that, and after that you can appear in any test series, and from there you can learn more concepts, and it is sufficient for your preparation. Sign the waveguide again, it has been already finished. Yes, Bhanushri, that is all about YouTube. That is all about YouTube only. So waveguide, if you are English student, sign. If you are English user, then the waveguide will start at least after 1 week. Okay, so waveguide will start after 1 week. Then you can join, but circular waveguide will be the separate topic, and that will be discussed in Hindi and English both, but not in this month. I will be discussing it in the next month most probably. Okay, Sai, so I think you have got your answer. Welcome, Bhanushri. Vishwanathan Sankar, this time circular waveguide is the most important topic in the waveguide, because whenever the gate changes its syllabus, they definitely ask the question from that new topic that they have added. In the past year also they have done so. Whenever they put something in the syllabus, they definitely ask the question from that topic. So that is why the circular waveguide become most important topic of the waveguide. Okay, when they added the radar and optical fiber in 2016, they asked two questions, one question from radar and one question from optical fiber. And in the next year also they asked a question from the optical fiber. After that they didn't ask any question from the optical fiber and radar, and now they have removed radar from the GATE syllabus. So that is why this year at least this circular waveguide is very important. So all of you, those who are watching video now, they should be aware that they cannot leave, all of you cannot leave this topic circular waveguide. You have to study from anywhere, whether I teach or if you get any material from anywhere, you have to study that. Okay, now after this sixth equation, we will apply the boundary condition, and the boundary condition says, boundary condition. So this boundary condition is, it says that the tangential component of electric field in medium 1 is equal to the tangential component of electric field in medium 2. Yes, Vishwanathan, I will definitely cover that topic, circular waveguide, but actually it is taking some time because I am right now busy in the different tasks, so that is why I am not able to finish that topic in the YouTube. So we'll do that. Wait. Okay, so boundary condition, the tangential component of electric field in the medium 1 and medium 2 are same. What are the tangential components? So if the z is equal to 0 is the boundary, okay, any variable which is constant is the normal component, and anything which is remaining is the tangential component. Like if I say x equal to constant, then x will be the normal component of the x equal to 0 plane, or x equal to constant plane, the x will be the normal, and the remaining variables are y and z. So y and z are the tangential component. Okay, so like that you have to decide which is the normal component and which is the tangential component. Okay, the variable which is constant, the direction of field in that particular direction is called the normal component. Like y is equal to -2, suppose I say y is equal to -2. So y is a constant, so that means the y is the normal component and the remaining two variables are x and z. So x and z are the tangential component. Okay, so in this way you have to decide which is the normal component and which is the tangential component. So out of this 6 equation, which one is the normal component and which one is the tangential component? Since the z is equal to 0 is the boundary, so z is the normal component and x and y become tangential component. So this x is the tangential component, this y is the tangential component, x and y tangential, x and y tangential. So we are saying that the total tangential component in electric field, boundary condition says at the boundary, and what is the boundary? Boundary is z is equal to 0. So when you put z is equal to 0, the total tangential component in medium 1. So total tangential component in medium 1 is the sum of incident wave and the reflected wave. So when you add the equation number 1 and 3, when you add equation number 1 and 3, you will get the total electric field in medium 1. So total electric field in medium 1 is sum of incident and tangential, incident and reflected, and the tangential components are, both the components which exist is actually tangential because both are having x component, and we have to substitute at z is equal to 0. So when you put z is equal to 0, you will get EI naught only. So these two are the addition of these two are the total electric field in the medium 1, and that is tangential to the boundary. Now the tangential component in medium 2, the tangential component in medium 2 at z is equal to 0 is ET0 from equation number 5. So this is ET0. Now if I divide it by EI0, we will get ER0 divided by EI0 equal to ET0 divided by EI0, and ER0 divided by EI0 is called the reflection coefficient. So this is known as the reflection coefficient and this is known as the transmission coefficient. So put it equation number 7. Okay, so gamma is known as the reflection coefficient. The gamma which we have written here is known as a reflection coefficient, and it is nothing but the ratio of reflected wave divided by incident wave. Reflected wave divided by incident wave is the reflection coefficient, and the transmission coefficient tau is equal to, tau is called transmission coefficient, and it is transmitted wave divided by incident wave. It is transmitted wave divided by incident wave, and especially the peak value of the transmitted wave divided by peak value of the incident wave. Okay. In general, we said like this, the transmitted wave divided by incident wave, but actually it is the peak value. As you can see that this ER0 and EI0 are the peak value of the reflected electric field and incident electric field, right? Now, there is another boundary condition, and another boundary condition is for the magnetic field. So boundary condition for magnetic field now we will apply. Boundary condition for magnetic field, it says that the HT1 is equal to HT2 at Z is equal to 0. So tangential component of magnetic field are also equal at the boundary, and the total tangential component in medium 1 is again the sum of equation number 2 and 4, and equation number 2 EI0 divided by eta 1, and equation number 4 is minus ER0 divided by eta 1. Okay. Now you can see that here equation number 2 and 4 at Z is equal to 0. These two equations, EI0 divided by eta 1 at Z is equal to 0, ER0 divided by eta 1 at Z equal to 0. Okay, and this is the minus sign. So this minus sign we have to write. And in the second medium it is ET0 divided by eta 2. Now if we take 1 upon eta 1 common and cross multiply it and divide it by EI0, we will get EI0 minus ER0 equal to eta 1 divided by eta 2 into ET0, and when we divide it by EI0 it is 1 minus ER0 divided by EI0 equal to eta 1 divided by eta 2, here ET0 divided by EI0. Now again ER0 divided by EI0 is defined as the reflection coefficient, so it is 1 minus gamma equal to eta 1 divided by eta 2 into tau. So this is equation number 8. So now we are having the two equations 7 and 8. Now adding the equation number 7 and 8, what we will get when we add the equation number 7 and 8? Adding this equation 7 and 8, what you will get? So when we add, we get 2 equal to tau plus eta 1 divided by eta 2 into tau. Okay, so now we will calculate tau here, 1 plus eta 1 divided by eta 2. So after the whole calculation, we will get 2 eta 2 divided by eta 2 plus eta 1. You can see this is the transmission coefficient. Now when we substitute the value of the transmission coefficient in equation number 7, we will get 1 plus, okay, 1 plus gamma is equal to tau. So here this gamma equal to, now we want to calculate the gamma because tau we have calculated, tau minus 1, and tau minus 1 means 2 eta 2 divided by eta 2 plus eta 1 minus 1. So after solving this, this is 2 eta 2 minus eta 2 minus eta 1 divided by eta 2 plus eta 1. So this is the gamma. Now after solving this, the value of gamma 2 eta 2 minus eta 2 will become eta 2. So this eta 2 minus eta 1 divided by eta 2 plus eta 1. This is what we get. So we are having these two values, the transmission coefficient and the reflection coefficient for normal incidence. This is for normal incidence. So everyone go to the Telegram and share the video once again, because now it is the time, generally most of the students join at this time. So now everyone go to the Telegram and share the video, and then come back, and then we will start the discussion further. Adarsh, Anand, what is your problem? What you are saying? You are from electronics and communication and you have the same problem as Bhanu Di. Okay, so Bhanu Shri was having the problem that she wanted to prepare. You are also from the instrumentation, Adarsh? Are you also from the instrumentation? And you want to prepare EMT, right? Is it the case? Okay, yes, you have written EC. Yes, sorry. And yes, you are from electronics and communication. Then, and if you want to prepare the EMT, right? You want to prepare EMT. Others, you want to prepare EMT. Good evening, Naman. How are you? Okay. Now, for others, if you are from EC students, I think you can understand Hindi, as I can see that Adarsh Anand Chaudhary, so definitely you are not from the South India, so I think you are able to understand Hindi. So for ECE students, if they want to prepare EMT right now, they can follow the EMT crash course in the main channel. In the main channel, that means in the GATE Academy channel. In the GATE Academy channel. Okay, already it has been finished, so you should go to that main channel and you should start watching all the videos from the beginning. Then you will catch up and you will be able to prepare some medium range problem. I am not saying that you will be able to solve all kind of questions and all the tough level questions, but yes, you will be able to solve medium range questions, that means easy to moderate type of questions you will be able to solve, and the tough question even the top rankers will not solve in the exam, that is for sure. If you ask any top ranker from the past exams, they will also they also leave those questions, the toughest question of the GATE, they also leave that, they also didn't solve that type of questions. So don't bother about the toughest question that will be asked in the GATE 21. So if you have not started the EMT yet and you want to prepare the EMT, you want to have some basic command over the subject EMT, and you want to solve at least 3 to 4 questions out of 6, then you can follow this EMT crash course in the GATE Academy channel, and after practicing some questions you will be able to solve a tough type of question also, but that depends on you, that how much hard work you will do. Yes, Vishwanathan, if you are EMT, if you are facing the problem in antenna, then if you if you are following this crash course, okay, if you are following this crash course, then antenna, when we will discuss antenna, it will be easy for you. In GATE Academy official channel, I completed coordinate system but getting stuck in plane waves. Yes, Vishwanath, then don't worry, when we will discuss antenna, it will become easy for you. And others, in the plane wave, if you are stucking, then maybe some more basics it is required for you. So you have to buy the full course then in that case, because if you are not able to understand from the crash course, then you have to buy the full course. That is, especially I will suggest to buy the live course of EMT from the GATE Academy, and that will, from there you will definitely understand. Yes, Kumar is saying that formulas and theorems are very important in EMT. Yes, it is. Welcome, dear others. So now, after this, the reflection coefficient and transmission coefficient, we will discuss the standing wave pattern ratio, VSWR. standing wave ratio. Standing wave ratio is denoted by S, and that is for electric field, and for electric field it is nothing but the maximum value of electric field divided by minimum value of electric field, and it is given by 1 minus 1 plus magnitude of gamma for electric field divided by 1 minus magnitude of gamma for electric field. This is the standing wave ratio for electric field, and for magnetic field it is the ratio of maximum value of magnetic field divided by minimum value of magnetic field, and it is ratio of 1 plus magnitude of reflection coefficient divided by 1 minus magnitude of reflection coefficient for magnetic field. So these are the two formula for the standing wave ratio. And what is the gamma h? So the gamma h is minus of gamma e, and gamma e is eta 2 minus eta 1 divided by eta 2 plus eta 1. Eta 2 minus eta 1, this reflection coefficient that we have calculated is actually for the electric field, and if you want to calculate it for the magnetic field, that is minus of this electric field. But because we will take the magnitude of it, that will not be changing the standing wave ratio, because we have to take the mod. So when you take the mod, you will get the same value whether it is electric field or magnetic field. But if you want to apply the reflection coefficient formula for magnetic field, then remember this thing, it is nothing but minus of eta 2 minus eta 1 divided by eta 2 plus eta 1. Now we will draw some patterns, standing wave patterns in certain condition. Okay. So standing wave pattern forms always in the medium where there are two waves, that is incident and reflected. Whenever the incident wave and the reflected wave added together, that is constructive addition will be there, then they form a standing wave ratio. Okay, so to form a standing wave ratio, there must be two waves, and that is happening in case of medium 1, because in the medium 1 there is an incident wave and the reflected wave. So the sum of incident wave and the reflected wave, constructive addition of the incident wave and the reflected wave, forms standing wave pattern. So this standing wave pattern is calculated in different cases, like case 1, when the second medium intrinsic impedance is greater than the first medium, eta 2 is greater than eta 1, then the standing wave pattern is formed like this, where when you observe the magnitude of electric field at the interface or the boundary, you will find that the electric field is having the maximum value at the boundary, that means z is equal to 0. And when you move in the negative side where z is minus lambda by 4 and z is minus lambda by 2 and then minus 3 lambda by 4 and so on, minus lambda, you will get the minimum electric field. When you travel the lambda by 4, you will get the minimum electric field. Here at this point you will get the minimum electric field. So this is a standing wave pattern for the case eta 2 greater than eta 1 of magnetic field. Yes, Rupali, what is the time of the live class daily? So this is happening in the 5 to 7. Generally we are taking the class between 5 to 7. Now if you want to draw the magnetic field, if you want to draw the magnitude of magnetic field, you will find that the magnetic field is minimum at the boundary in case of eta 2 greater than eta 1, and after traveling the distance of lambda by 4, you will get the maximum magnetic field. Like this. This is what you are traveling in the negative z direction. So this is the electric field, this is the magnetic field. When you see or when you observe the electric field at the boundary, you will get the maximum value of electric field if this condition is satisfied. Or you can say that whenever you will be having the standing wave pattern, and when you observe in the standing wave pattern maximum electric field at the boundary, then you can conclude that eta 2 is greater than eta 1. And if it is so, then the standing wave ratio is given by the ratio of eta 2 divided by eta 1. This is very important and useful formula. Okay, standing wave ratio is ratio of eta 2 divided by eta 1 whenever the electric field maxima occurs at the boundary or the magnetic field minima occurs at the boundary. So if any of these two conditions you find somewhere in the standing wave pattern, you can conclude the formula for the standing wave ratio, which is eta 2 divided by eta 1. And once you calculate the standing wave ratio, you can calculate the magnitude of reflection coefficient. The magnitude of reflection coefficient is given by s minus 1 divided by s plus 1. Okay, if you apply the componendo dividendo formula in this particular expression, you will get the magnitude of reflection coefficient as s minus 1 divided by s plus 1. And remember also that the reflection coefficient is having the range between minus 1 to 1, it has been asked in GATE, and the standing wave ratio is having the range from 1 to infinity. So this is the range of the reflection coefficient and the standing wave ratio, that is also important. One more thing that you should write it here, the distance between the two successive maxima or minima is lambda by 2, that we will draw in the second case and also write. So in case 2 is when the eta 2 is less than eta 1, and in such case if you observe the standing wave pattern, you will find that the electric field is minimum. You will find the electric field is minimum at the boundary, minus lambda by 4, minus lambda by 2, minus 3 lambda by 4 and minus lambda. So this is the magnitude of electric field. This is the magnitude of electric field, and you can see that in this particular case you are getting the minimum electric field at the boundary. Here at the boundary we were having the maximum electric field, from there we conclude that eta 2 is greater than eta 1 or vice versa. Here we can see that the electric field minimum is occurring at the boundary, so we can say that eta 2 is less than eta 1 or vice versa. And if you will draw the standing wave pattern for the magnetic field, you will find that the maximum magnetic field occurs at the boundary. So at z is equal to 0, you are getting the maximum magnetic field. Like this. So in this way we are having the standing wave patterns, and these standing wave patterns are very important, we will see in the numerical. And in such cases the standing wave ratio is given by, this is E maximum divided by E minimum, or in terms of eta, the eta 1 is greater, so this is eta 1 divided by eta 2. Why we are writing eta 1 divided by eta 2? Because we always want to have the standing wave ratio greater than 1 or equal to 1. You can see that the range of the standing wave ratio is always greater than 1. So if you are having the two impedances and you want to make the ratio greater than 1, so you have to put the maximum value or the greater value in the numerator, then only you will get the ratio greater than 1. Yes, Rupali, so the time duration is 2 hours, as I said, 5 to 7. Okay, now write the distance between the distance between successive maxima or minima is lambda by 2. That is important. The distance between the successive maxima or minima is always lambda by 2. You can see this is the maximum, this is the maximum. When you will measure the distance, you will find that this is lambda by 2. Here also this is the maximum, this is the maximum. When you will find the distance, you will get lambda by 2, like that. Now, write next definition, percentage reflected power. Percentage reflected power is given by mod gamma square into 100, and percentage transmitted power. Percentage transmitted power is given by 1 minus mod gamma square into 100. Okay, so write this formula also, and now we will be solving the questions. So from the workbook we will solve the question, and I am writing the question number 15, it is there in the workbook. Question number 15, in free space z less than 0, let me draw with the diagram, with the help of diagram. This is z equal to 0, let us say boundary, and this is the free space which is z less than 0, okay, and there is a lossless medium, okay, this is the lossless medium, and here it is epsilon is equal to 2 epsilon naught, and mu is equal to 8 mu naught. So this is epsilon 2 and mu 2, and this is the first medium. So here epsilon 1 is equal to epsilon naught, and mu 1 is equal to mu naught, because it is free space. Okay, it is normally on the z greater than 0 plane, and the magnetic field is given here. The expression, this is z less than 0, it is medium 1, and it is z greater than 0, it is medium 2. The incident magnetic field is given, so Hi equal to 10 cos of 10 to the power 8 t minus beta z and Ax cap, and that too in milliampere per meter it is given. That too in milliampere per meter it is given. Okay, now you can see that we have to find the reflected electric field. So let's find first electric field of incident wave. So this electric field for incident wave we can calculate EI is equal to EI0, and it is cos of omega t minus beta z, and the direction of electric field. This would be the expression because it is free space, so there will be no alpha. So here what we know, that is only omega that we know. We don't know about EI naught, we don't know about beta, we don't know about AE. So let's calculate one by one. Let's calculate beta first. So beta is omega by c. For the free space, the beta is omega by c, and because it is first medium, let's write beta 1. So you should write beta 1 here. It would be good practice. So omega is 10 to the power 8 and velocity is 3 into 10 to the power 8. So you will get 1 by 3. So beta 1 is 1 by 3. Now calculate the direction of electric field. The direction of electric field is calculated by AH cross AE AK. Okay. So of incident wave. Unit vector for incident wave. Unit vector for incident wave AEI. So AEI is the unit vector of the AH and AK. So for the incident magnetic field, the direction is AX and wave is traveling in the positive Z direction. So AX cross AZ is minus AY. So the second term, that means the incident electric field is in the negative Y direction. And the last one that we have to calculate, we have calculated these two. Now we have to calculate EI naught. So this EI naught is equal to eta 1, that is the impedance of the first medium, and the magnitude of the incident magnetic field. So this is 120 pi and it is 10 into 10 raised to power minus 3 because it is in milliampere. So now when you solve it, you will get 1200 pi millivolt per meter. So now you have calculated all the three parameters. And once you calculate all the three parameters, you will be able to write the incident electric field, and this is EI is equal to, this is 1200 pi and cos of omega is 10 raised to power 8t minus beta is 1 by 3 and direction is Z, and this is in minus Y direction, minus AY, and this is millivolt per meter. So this is the incident electric field. First we have calculated the incident electric field. Even it is not asking in the question, but we are calculating this value. Now let's calculate the reflected electric field. To calculate the reflected electric field, we have to write the expression. So let's write the expression for the reflected electric field. So the general expression will be ER naught cos of omega t plus beta 1 into Z plus, because if the wave is incident, if the incident wave is traveling in the positive Z direction, then the reflected wave will be traveling in the negative Z direction. So here it will be plus, and it is now direction of the electric field remains same. Okay, so the direction of electric field should always be remain same because in the theoretical part you can see that in the incident wave, transmitted wave and the reflected wave, we have kept the direction of electric field constant. Okay, so you can see in the starting when I draw the diagram for the normal incidence, I have kept the direction of the electric field constant. So that is why the direction of electric field is constant. So here we have to calculate this ER naught and beta 1 we have calculated. So only we have to calculate is ER naught, and this ER naught can be calculated by the reflection coefficient only. This is ER naught divided by EI naught. So this ER naught is EI naught. EI naught you have calculated, which is 1200 pi into 10 to the power minus 3, and EI naught into eta 2 minus eta 1 divided by eta 2 plus eta 1. So when we will solve this, what is that eta 2 minus eta 1 divided by eta 2 plus eta 1? So if you will calculate eta 2 here, you know that for the lossless medium it is root over mu r 120 pi root over mu r2 divided by epsilon r2. So mu r2 is 2, 2 divided by 8 divided by 2, 8 divided by 2 is 4, 4 in root over 4 is 2. So this is 240 pi. So okay, so we will write it here 240 pi minus 120 pi. Okay, so this is 240 pi minus 120 pi divided by 240 pi plus 120 pi. So this will be 1 by 3 because 120 divided by 360 and it will be 1 by 3. So you will get ER naught is 1200 pi divided by 3, that means 400 pi into 10 raised to power minus 3 volt per meter. Now we will write the expression which is ER is equal to 400 pi cos of omega is 10 raised to power 80 plus 1 by 3 into Z and direction is minus y and it is millivolt per meter. So when we keep this minus sign in front, this minus 400 pi cos of 10 to the power 80 plus 1 by 3 Z and AY cap millivolt per meter. So this is the expression of the reflected electric field. Now you can see this. So according to the option, the correct answer would be option C, because in option C we are having minus 400 pi. Now we want to calculate the transmitted electric field. Okay. So now if you want to calculate the transmitted electric field, it is ET is equal to ET0 cos of omega t minus beta 2 into Z, because it is traveling in the same direction. The incident wave and the transmitted wave travels in the same direction, and because it is traveling in the medium 2, we will keep the beta 2. We will write the beta 2 and the direction of electric field remains same in all the case. So that is why we will write this minus AY cap. You should keep the direction of magnetic field same. Now what is this gamma? Gamma was 1 by 3 and we know that this tau is equal to 1 plus gamma, which is 4 by 3. So the reflection coefficient is 1 by 3, transmission coefficient is 4 by 3. Now what is the value of this ET0 now? So ET0 divided by EI0 is nothing but tau, that is the transmission coefficient. So ET0 is equal to tau into EI0, and what is that tau? Tau is 4 by 3 and EI0 is the incident wave which is having the 1200 pi in millivolt. So when you solve it, you will get 1600 pi in millivolt per meter. Now when we will write all the values here, you will get 1600 pi cos of omega means 10 raised to power 80. Now beta 2 is left. Now can you calculate the beta 2? So yes, so beta 2 is given by omega by c root over mu r into epsilon r for lossless medium, and omega by c, that means this one omega by c we have calculated, which is 1 by 3, and root over mu r into epsilon r, that means 2 into 8. So 2 into 8 is 16, 16 root over 16 is 4, again it is 4 by 3. So the transmission coefficient and the value of beta are same, but here 4 by 3 we are getting and minus AY, and it is in millivolt per meter. So accordingly you can write the transmitted electric field, and if you keep the minus sign in front, and according to that we will check the option, and it is minus 1600 pi. Yes, option A is correct for the transmitted electric field. Okay. Okay. So now we want to write the magnetic field. Okay. Now we want to write the magnetic field, and that is reflected magnetic field and the transmitted magnetic field. So the reflected magnetic field will be having the expression HR is equal to HR naught cos of omega t plus beta 1 into Z and AHR cap. Okay, because we are writing the reflected electric field, so it will be traveling in the negative Z direction, and here we have to find only two parameters. The omega we know, beta 1 we know, we have to find the direction of magnetic field and the peak value of magnetic field. So the peak value of magnetic field can be calculated by ER naught divided by eta 1. And what is that ER naught? So you are having the ER naught, we have calculated it 400 pi, that is in millivolt, and eta 1 is 120 pi. So when you solve it, you will get 10 by 3. 10 by 3, it is milliampere per meter. And another thing is you have to find the direction. So direction is in the direction of propagation and the direction of electric field, the cross product of these two unit vectors. So the wave is traveling in the negative Z direction and the electric field is minus Y. So AZ cross AY you will get minus X. AZ cross AY is minus X. So you will get the negative X direction. So minus 10 by 3, 10 to the power 8 plus, yes, option B will be coming, right? Now the correct answer will be option B. HR is equal to, it is 10 by 3 and cos of 10 to the power 8 t plus 1 by 3 into Z, this is minus AX, and it is in milliampere per meter. You will get the HR. Now, yes, you can calculate the transmitted magnetic field also. HT is equal to HT0 cos of omega t, because the wave is traveling, so the positive Z direction will be there, minus beta 2 Z and AHT. Again you have to calculate these two parameters. These two parameters you have to calculate. HT naught, so we will find HT naught same as this ET naught or HR naught. So this is ET naught divided by eta 2. ET naught, how much was ET naught? ET naught was 1600 pi, that is in milli. So 1600 pi divided by 240 pi, the eta 2 was 240 pi, right? We had calculated that before. So this is 40 divided by 6, and it means 20 by 3 milliampere per meter. Yes. Now the direction AHT, we will apply the same formula of unit vectors AKT and AET, and it is the direction of wave is propagating in the positive Z direction and the electric field is minus Y direction. So you will get plus X now. Electric field was minus Y direction, so it is now plus AX. So now when we write the expression of magnetic field, so HT is equal to HT naught, which is 20 by 3, and cos of omega, that means 10 to the power 8 t, minus beta 2, beta 2 means 4 by 3 into Z, and the direction is AX cap. So this is the transmitted magnetic field. This is how you can calculate, and it is also in milliampere. Okay. So in this way we have calculated all the 4 fields that has been asked in the question. So we have solved from 15 to 18. Now next is question number 19, and in this question the standing wave pattern is given. This is the peak value of electric field. The standing wave pattern is given. This is 0.5 and 1.5. It is 0, it is -1, it is -2 and -3 and so on. So now it is asking about the permittivity of the second medium. Actually it is traveling from air to a non-magnetic dielectric. Okay, so it is non-magnetic, that is mu r equal to 1, and it is dielectric medium. So we want to calculate the epsilon r for this non-magnetic medium. This is the boundary. Okay, so this is the boundary here. This z is equal to 0 is nothing but boundary. So as we can see that since E minimum is occurring at the boundary, E minimum occurs at boundary at z is equal to 0, we will conclude that eta 2 is less than eta 1. Since E minimum occurs at z is equal to 0, we will conclude that eta 2 is less than eta 1. So now the standing wave ratio is eta 1 divided by eta 2. And what is that standing wave ratio? So standing wave ratio is nothing but maximum electric field divided by minimum electric field. So 1.5 divided by 0.5, that is equal to 3. So standing wave ratio is 3. Eta 1 is 120 pi. Eta 2 is 120 pi divided by root over epsilon r. Because this is a non-magnetic medium, and for non-magnetic medium and that too lossless dielectric, 120 pi divided by root over epsilon r mu r, and 120 pi root over mu r divided by epsilon r. Mu r is 1, so divided by epsilon r will left. So we will get 3 equal to root over epsilon r. Hence the epsilon r equal to, when we square it, you will get 9. So epsilon r is equal to 9. No, Lakshmi, don't go to the milliampere per meter. We have already written in milliampere per meter. Milliampere per meter it is. Lakshmi, did you get it? So we also know that the distance between two maxima, is equal to lambda by 2, and if you measure the distance between the two maxima or the minima, you will get the value lambda by 2 is equal to 2. So you will get lambda is equal to 4 meter, and because we are talking about air, so in air it is C upon F is equal to 4. So from here F is equal to 3 into 10 raised to power 8 divided by 4, that is nothing but 75 megahertz. So you will get the 75 megahertz frequency. What to explain? I am not getting your question, Lakshmi. Milliampere per meter, it is already there in milliampere per meter. Everything we have calculated in milliampere per meter. Then what is left in this explanation? Okay, in the question number 20, it is given that a uniform plane wave incident on a plane surface of a dielectric material is reflected with VSWR 3. So, in question number 20, it is given that standing wave ratio is 3, you have to calculate the percentage reflected power. Okay, so percentage reflected power is given by 1 minus mod gamma square, mod gamma square into 100. Mod gamma square into 100. So now what is the reflection coefficient? So magnitude of reflection coefficient is S minus 1 divided by S plus 1. So it is 3 minus 1 divided by 3 plus 1. Hence we get 2 by 4 means 1 by 2. So magnitude of reflection coefficient is 1 by 2. So percentage reflection coefficient from here, this is the percentage reflected power. Percentage reflected power is 1 by 2 square into 100. Hence we get the 25%. So 25% you will get for question number 20. Okay. Now coming to the next question, question number 21. A plane wave is traveling from free space to is incident normally on a medium epsilon r is equal to 4. Epsilon r is equal to 4 and the percentage transmitted power now we have to calculate. Okay. In question number 21, percentage transmitted power you have to calculate. And the percentage transmitted power is 1 minus mod gamma whole square into 100. So this is the formula. And epsilon r is equal to 4 is given. It is traveling from air to the medium where epsilon r is 4. Okay, it is traveling from air to epsilon r is equal to 4. So now it is traveling from air, that means eta 1 is 120 pi. What is eta 2? It is traveling from 120 pi, that is air to epsilon r is equal to 4. That means how much it is? 60 pi. So what is the reflection coefficient? It is eta 2 minus eta 1 divided by eta 2 plus eta 1. So it is 120 pi minus 60 pi divided by 120 pi plus 60 pi. So it is 1 by 3 with eta 2 is 60, right? So eta 2 is 60 and it is 120 pi. So it is 60 upon 180, 1 by 3 with minus sign. Okay, so now we have to calculate from here 1 minus 1 by 3 square, that is 1 by 9, and now we don't need to calculate in the percentage. So the transmitted power is how much of the incident wave? So it is 8 by 9. Okay, fraction of incident power that is being transmitted. Fraction of incident power that is being transmitted. Eight by 9 it is coming, which is option A. Okay, so is it clear to everyone? Okay, so we have finished this part, that is the reflection of plane wave at normal incidence. So far whatever we have discussed, I think it is clear to you. We have already taken around I think 14 to 15 hours we have completed, and we have discussed so far the coordinate system, the del operators, the application of the del operators in the scalar and the vector, that is curl and divergence, gradient, and what is the important point, some vector identities we have seen, and also we have discussed the plane wave equation. So what is the plane wave equation, from where it comes, all kind of Maxwell equation, all the 4 types of Maxwell equation in the form of the differential or in the integral form. After that we saw that how the wave propagates through the different mediums, like whether it is a free space, lossless, lossy, conductor. Then we discussed about the skin depth. Then we also discussed about the low loss medium, what is the condition for a medium to have a low loss, and also after that we discussed about the attenuation, phase shift, etc. We have all discussed. And after that we discussed about the when the wave travels through any medium, how much power it travels and in which direction it travels. The power travels in the direction of wave propagation. So this is also we have discussed. And after that we saw today the reflection of a plane wave from the normal incidence. Whenever the wave incident normally from in the boundary, how much part is incident, how much part is transmitted, that we discussed. Okay, and that is very important. The VSWR, standing wave ratio, not voltage standing wave ratio, it is electric field standing wave ratio, and the magnetic field standing wave ratio, reflection coefficient for electric field, magnetic field. What is the condition of the standing wave pattern when the eta 2 is greater than eta 1, eta 2 less than eta 1, range of the reflection coefficient and range of standing wave ratio. Up to this point we have seen, and in the next class we will be discussing about the reflection coefficient, reflection of a plane wave at oblique incidence, and the oblique incidence we will discuss tomorrow, and in depth we will cover the oblique incidence in depth, and after that it will take 2 classes to cover the reflection coefficient of plane wave at oblique incidence. That is very important. I will tell you each and every point very clearly in depth, and after that we will be solving the questions from the oblique incidence. Okay, so this is all about the today's session. So is it clear to everyone whatever we have discussed so far in the today's session? Is it clear? So can you guys tell me, is it clear or not? Is it clear or not? Yes, anything would you like to ask? Anything would you like to ask? Anything would you like to ask me? How many subjects you have prepared till now? Up till now, how many subjects you have prepared? How many subjects you have prepared? Because you guys are self-study students. Okay, so yesterday we discussed that how many of you are self-study students. So yes, Hemant, what are those 4 subjects that you have prepared? What are those 4 subjects that you have prepared? So you are running behind, so you have to move fast. Okay, in the next 2 months you have to finish all the 10 subjects. November and December, up to 31st December you have to finish all the subjects, Hemant. Then only in the January you will revise, you will give test, and then you will appear in the exam in February. Yes, Rupali, thank you. Signal, network, control and digital. Okay, so you have completed all the common subjects, and now you have to move into the core subjects, like you have moved into the EMT, and also you have to start preparing the communication, because the communication crash course is already there in the GATE Academy Global, and that is more than sufficient if you want to prepare the communication. That is very well covered in the crash course. So I think you were following. So can you tell me you were watching or not that communication crash course in the GATE Academy Global channel? I will not tell you to follow the main channel right now, because you are not having that much time. Okay. Yes, I have been watching communication and completed 6 videos. Okay, only 6 videos. There are 31 lectures. You have to finish all the 31. Okay, so along with this EMT, in the morning you should watch this communication. Okay, and practice the question. Okay, so ask me more. If you are having any more questions, you can ask. All of you like the video? All of you have liked the video or not? If anyone who is left who have not liked the video yet, like the video. Okay, so share with your friends also why they are not coming, because sometimes they suddenly come to the class, and alternate days they are coming and then going. Yes, Lakshmi, thank you. I am expecting it from you, because you always watch the video from the beginning, so definitely you will be liking the video every day, and thank you for that. Thank you for liking this video and sharing the video. I am sure that you will be sharing the video in other group also. Thank you, Rushikesh. Okay, so let's finish the session, and we will meet tomorrow at 5 p.m. Sir, is superatudine important? No, superatudine is not that much important. If you want to prepare superatudine receiver, then it is there in the main channel in the English language only. Okay, so search concept of image frequency. Hemant, search concept of image frequency, you will get my video in the main channel, GATE Academy channel, in English only. Yes. Thank you, Omkar. Love you, dear. Love you so much. And thank you for appreciating, coming here and appreciating. Thank you. Okay, so let's end the session, and we will meet tomorrow at 5 p.m. Good night.